Hello students, this is our last video of the year. It's on infinite geometric series. So in the previous video we talked about how to tell the difference between finite and infinite. So we're going to look at finding the sum of an infinite geometric series, and that is if it exists. So you have to remember that we have two different types of infinite series. We have diverges, or series that diverge, and we have series that converge. So if it converges, then it will exist, but if it diverges, then it doesn't exist. So let's look at this first example. We have the series 5 plus 5/3 plus 5/9 plus 5/27 plus, and it goes on forever. So the first thing that you want to do is you want to figure out what the rate is. So what is it changing by? And so we need to find out what the R is. So one thing that you can do is, remember, you can compare two numbers and see what it's changing by, and you can see that the numerator is not changing, that it stays 5, but on the bottom it's being multiplied by 3 each time. So if it doesn't change on top, then the numerator is 1, and whatever it's changing on the bottom, since it's being multiplied by 3, then the R is 1/3. Okay, now our summation formula for infinite geometric series is this. It's S equals the A sub 1 over 1 minus R. And remember, this is when R is less than 1. So if it's less than 1, then then the series converges, and so we can find the sum. Well, so this R is less than 1, so let's go ahead and figure out what the sum is. S equals, the A sub 1 is your first term, which is 5, and then it's 1 minus the R, which is 1/3. And so if you figure out what this is using your calculator, it comes out to be 15 over 2. And go ahead and just leave it as a fraction. So that is what the series sums to. Okay, example 2, we have 200 plus -50 plus 12.5 plus ... So the R, and remember, in order to tell what the R is, you could compare two numbers by dividing them. So if you cannot tell exactly what the R is, take two numbers. So let's take the -50 and let's divide it by the previous one, which is 200, and you'll see that the R is -1/4. Okay, so like I said before, the R has to be less than 1, and it's really the absolute value of R that has to be less than 1 for it to have a sum. And so the absolute value of -1/4 would be 1/4, and that is less than 1. So we can find out what the sum is. So our formula, S equals, the A sub 1 is your first term, so 200 over 1 minus a -1/4. Okay, so the minus negative is going to change to a plus, and then if you go ahead and you enter this in on your calculator, it comes out to be 160. So that's what the sum comes out to be. Okay, looking at these next two examples, they have the series written already in sigma notation, and so this right here represents the explicit formula. And if you'll remember, if you'll look back at your explicit formula, this number right here that's in parentheses, that represents your R. So your R for this problem is 1/2. So it is less than 1, so you can find the sum. So our sum is, we're going to take the first term. Well, you need to go ahead and figure out what the first term is. So A sub 1 would mean that I'm plugging in a 1 for n, so I would have 4 times 1/2 to the 1 minus 1 power. 1 minus 1 is 0. 1/2 to the 0 power is 1, so this would be 4 times 1 So your first term is 4. So you'll recognize, and you can also, I guess, take that straight from the formula, that this very first number is going to be your a sub 1. So a sub 1 is 4, so we're going to put that in the numerator, over 1 minus the r, which is 1/2. And if you type this in on your calculator, you get 8. Okay, you go ahead and figure out what the answer is for the next problem, and when you're ready to check your answer, go ahead and hit play. Okay, so the summation came out to be 3/5, so hopefully you got that as your answer. Okay, in our last example for the night, we have the sigma notation again. Remember that the 1/3 represents your a sub 1, and this number that's in parentheses represents your r. So my r is equal to 5/2, which is the same thing as 2.5. So what you'll notice is that the absolute value of r is greater than 1, and so when it's greater than 1, that means that this diverges. Therefore, no sum exists. So that's always why it's really good to check your r. The only way that you can get a sum on an infinite geometric series is if the absolute value of r is less than 1. Okay, so that's it for tonight. Come to class ready to work.